Dear students, let us discuss 26/8/2020 physics assignment. Question number 1. A sample of gas in a box is at a pressure P0, temperature T0. So initial pressure P1 is equal to P0 and temperature T1 is equal to T0. They have given. If the number of moles is doubled, not molecules, number of molecules. So you can say that number of molecules N1 is equal to N, N2 is equal to 2N, doubled. And keep the kinetic energy is constant. K is equal to constant. K is equal to constant. Then find the temperature and pressure will be. See, we know that K is equal to 3/2 PV or nRT. You can write N as capital N. Also you can say that 3/2 N or T1, N1 or T1 is equal to 3/2 N2 or T2. Now 3/2 or gets cancelled. N1 T1 is equal to N2 T2. N1 is N, T1 is T0 and N2 is 2N. T2 we should find, Nn gets cancelled, T2 is equal to T0/2. They asked final temperature T2 and final pressure is equal to question mark. Now T2 is T0/2, let us see the final pressure. We know that PV/T is equal to constant. From this we can write P1V1/T1 is equal to P2V2/T2. Now as per that relation, if pressure, volume and temperature changes, then final pressure P2 also equals to initial pressure P1 based on the relation. If you have keep the kinetic energy is constant, we know the relation kinetic energy, even you can write by another step. This is one method, even you can do it by another method. K is equal to 3/2 PV. If K is constant, P is also going to be constant, hence final pressure P2 is equal to same P0, hence option 4 is correct. Next, question number 2. Question number 2. Now have a look on the question number 2. The kinetic energy of translation of 20 gram of oxygen. 20 gram means small m, 20 gram oxygen, capital M, 62s are 32. At 47 degrees Celsius, that is 320. T 47 plus 273, that is equal to 320 degrees Celsius. Then the question is that what is the kinetic energy has given, then they ask you to find what is the translation energy. Now see, we know that K is equal to 3/2 PV or 3/2 nRT. So K is equal to 3/2, N is small m by capital M into RT. Small m is given, capital M is given, R is given, T is given. By simplifying all these values, you are supposed to get the final value as 2490 joules. This is the second question. Now let us have a look on the third question. See, question number 3. In a diatomic molecule, the rotational kinetic energy at a given temperature, we know that it is 2/3 of translatory kinetic energy as per the theory basis. Next, fourth question. Have a look on the question number 4. A light container having a diatomic gas enclosed with its moving with the velocity v. Mass of the gas is v. So velocity v. Mass is capital M, mass of the gas, and number of moles is N, number of moles. Number of moles is N. The kinetic energy of gas with respect to ground they ask. So whenever they have given the diagram, this is mass of the gas is equal to capital M and temperature is equal to capital T. It's oriented along this direction. Then what is the kinetic energy of the gas? Generally half mv square. With respect to ground, in the sense Ke is equal to, with respect to half mv square, with respect to gas, diatomic gas, F by 2 nRT, degrees of freedom. Hence we can say that for bioatomic gas, F by 2 nRT. F is 5 rho, so that is 5 by 2 nRT. Now total kinetic energy is half mv square plus 5 by 2 nRT. This can be the correct answer for the fourth question. If they did not ask you with respect to the ground, you can directly go for the formula. Whenever they ask you to find with respect to the ground, then you can make the formula K is equal to half mv square plus 5 by 2 nRT. This is very important. Next, problem number 5. Fifth problem. Now see, a spherical balloon of volume V is equal to 4 into 10 power 3 centimeter cube, containing a helium at pressure P is equal to 1.2 into 10 power 5 Pascal. Then how many moles of helium are in balloon if average kinetic energy of the helium is given? Ke is equal to 3.6 into 10 power minus 22 joules. They ask to find number of moles. We know that by ideal gas equation PV is equal to nRT. From this we can say N is equal to PV by RT. In the problem, pressure is given, volume is given, you must convert the units. R you know, but you do not have T there. How to find T? So you can get kinetic energy Ke is equal to 3 by T RT. Now whenever you are going to be find Ke is given, R you know 8.3, from that you are going to get T value. The T value you are going to be substitute, you are going to get number of moles. So this is the way how, whenever they have given number of moles, N is equal to PV by RT. Then you know very well, K is equal to 3 by T RT. Now from this you are going to find the temperature, substitute the temperature here, you are going to get the answer. Yes. Next, have a look on problem number 6. Sixth problem. See, sixth question. Now, question number 6. The value of universal gas constant is 8.3 kappa. And the mean kinetic energy of Ke you need to find. They given 32 grams of oxygen. N is equal to small m by capital M. Small m they given 32 grams. For oxygen, capital M also 32. Then of oxygen at minus 73. So they have given temperature as minus 73. So you must notice that T is equal to minus 73 plus 273. So T is equal to 200 Kelvin because it is in Celsius. Now what they ask to find in the question, they ask to find the value of everything is given, mean kinetic energy you need to find. So the question is very direct. Mean kinetic energy formula is that Ke is equal to, what is that? 3 by 2 nRT. Either 3 by 2 PV or 3 by 2 nRT. From this you can say that Ke is equal to 3 by 2, N is weight 2 by molecular weight into RT. M is given, capital M is given, R is given and T is given. By substituting you are going to get the kinetic energy. This is the way how you are supposed to solve that problem. Next, have a look on question number 7. Seventh question. See, at what temperature the mean kinetic energy of hydrogen molecules increase to such that will escape out from the gravitational field over? At what temperature you should find the mean kinetic energy of hydrogen molecules? Hydrogen, you know, N. Hydrogen molecule they have given N small m by capital. They did not give how much mass. Molecules increase to such that will escape out gravitational field. How much temperature should be required. They have given escape velocity as 11.2 kilometer per second. But we know very well Ke is equal to 3 by 2 RT because they need to find the temperature. But Ke you can read it as half mv square is equal to 3 by 2 RT. Now it is very well 2 gets cancelled and mass you know very well by substituting the value of how many moles they have given, they did not given anything. So mv square is equal to 3 RT. You are going to get mv square is equal to 3 RT. Now you need to find temperature. M is given for oxygen. Escape velocity is given 11.2. R value already is a constant. By substituting you are going to get T value. It is approximately 10,059. So this is the way how you are supposed to find. Whenever they have given escape velocity, then kinetic energy can read in the form of half mv square is equal to 3 by 2 RT. By simplifying, you are going to get this relation. Next, have a look at problem number 8. Problem number 8. See, at what temperature does the average translated kinetic energy of a molecule in a gas becomes equal to the kinetic energy of an electron accelerated from rest through a potential difference of 1 mole? Whenever they have given Ke is equal to 3 by 2 RT, but kinetic energy you can relate Ke is equal to Vq. Now by simplifying, K is equal to 3 by 2 RT, that is equal to K is equal to Vq. By simplifying the two equations, you are going to get 3 by 2 nRT. In the terms of weight by molecular weight, you can write 3 by 2 nRT. Small Avogadro number of moles by Avogadro number. R by N you can write Boltzmann's constant. So you can write 3 by 2 kT is equal to Vq. So 3 by 2 kT is equal to V 1 volt Q. Charge of electron 1.6 into 10 power minus 19 coulomb. By simplifying that formula, you are going to get T value. K they given in the bracket 1.38 into 10 power minus 22. Now K is given. V is 1 power 1. Q is charge of electron 1.6 into 10 power minus 19. You are going to get T value. By simplifying that relation, now you can solve the problem. Next. Problem number 9. Ninth problem. See, the question is very direct. The average kinetic energy of a gas at minus 27 degrees Celsius. T1 is equal to minus 23 plus 273, that is equal to 250 Kelvin. T1. That pressure P1 is equal to 75 centimeter. And Ke is given, average kinetic energy is equal to 5 into 10 power minus 14 of H2. The mean kinetic energy of O2 T2 is equal to, for given 227 plus 273, that is equal to 500 Kelvin. At pressure P2 is equal to 150 centimeter. Then Ke2 is equal to question mark. We know very well Ke is equal to 3 by 2 nRT. Now Ke is directly proportional to T. Ke1 by Ke2 is equal to T1 by T2. T1 is 250, T2 is 500 because it is kinetic energy is always depends only on absolute temperature. Now by using the relation Ke1 by Ke2 is equal to T1 by T2, you are going to get the direct answer. Just have a look on the question number 10. 10th question. Tenth question. The temperature at which protons in proton gas would have enough energy to overcome Coulomb barrier of 4.14 into 10 power minus 14. The energy is given 4.14 into 10 power minus 14 joule. then you need to find at what temperature these things will be happen. We know very well Ke is equal to 3 by 2 nRT, or in Boltzmann's constant we can write 3 by 2 kBT. So from this Ke they have given, Kb is given, from that you are going to get the temperature. T is equal to 2 by 3 Ke by Kb. By simplifying Ke and Kb Boltzmann constant, they have given the value 1.38 into 10 power minus 22. By substituting Ke as 4.14 in 10 power minus 14, Kb as 1.38 in 10 power minus 23, 3 by 3, you are going to get the final absolute temperature. So students, this is the way how you can solve the problems related to these all concepts whatever I explained are related to kinetic energy, kinetic theory of gas, kinetic interpretation as well as ideal gas equation. So you must have exam how to do kinetic energy equation K is equal to 3 by 2 PV. By using ideal gas equation, how to get PV is equal to nRT, PV is equal to small m by capital M into RT, PV is equal to n by Na into RT. So PV is equal to 3 by 2 kBT. Like that you can substitute all these ways. Thank you very much.